right, it's our last new topic for chapter 5, where we're going to be talking about implicit relations. So when we've done implicit differentiation, but how can we explore the behaviors of the graph of implicit functions, right? How do we find critical points of implicit functions? So we've been talking about our implicit relations, right? Because we've been talking about functions. This should say relations because it's not a function, right? Um, so how can we identify critical values for these implicit relations? So let's look at this graph here. It says x squared over 4 minus y squared equals 1. It's graphed below. I'm just going to label my quadrants because we're going to use those to answer some questions. Okay, so remember those. So this first question says, where does this graph have vertical tangents? Okay, well, let's do this part for vertical tangents. So that would be here and here, right? So we can say that there are vertical tangents at x equals plus and minus 2. Okay, what about this second part? Where does it have horizontal tangents? Nowhere, right? So I'm just going to write no horizontal tangents. Just looking at it, I don't see any horizontal tangents. Okay, so now this second question is asking me, in what quadrants is this curve increasing? So where does it have a positive slope? Well, it's has a positive slope, so it's increasing in quadrant 1 and in quadrant 3. And then where is it decreasing, the other half of the question? Well, that is in quadrant 2 and quadrant 4. Okay, so now let's find dy dx. Okay, so I'm just going to rewrite the function like this. 1/4 x squared minus y squared equals 1. So now let's derive it. Let's find dy dx. I'm just going to do that, right? So then I would end up with what? I would end up with 2/4 x minus 2y dy equals 0. Okay. Now let's solve for dy. So I'm just going to give myself a little space. So dy is going to be equal to -1/2 x, right? Because that's 2/4, plus, what am I doing here? So let me make sure I do this right. So I take that over there, that's -1/2 x. I'm gonna work it all out because my brain is tired. I've been making too many videos today, but we're gonna get this done with each other. Okay, so now I can divide by -2y, divide by -2y, and what do I end up with? dy equals -2/4 divided by -2. So that's 0.5 divided by 2 is 1/4, right? X. You still have an x on top and a y on the bottom. So that can be written as x over 4y. Yes. Okay. That matches what I got when I did this before. My brain still works. So there is my dy, x over 4y. So the reason we did this was so that, because number 4 is asking us, how does that prove, how does that support my answer for questions 1 and 2? So let's look at this. When is dy greater than 0? When is this thing greater than 0? Well, it's greater than 0, what? When x and y have the same sign, or when they both are negative, right? Or if they're both positive, right? If they're both negative or both positive, you end up with a positive dy. So when x and y have the same sign. Okay, in what quadrants do x and y have the same sign? In quadrant 1 and quadrant 3, which is exactly what we said here, right? That's when it's increasing. And then the same is true. When is dy negative? Well, it's when they have opposite sign, right? And that would be when in D's 2 and 4. So when it's decreasing. So we kind of proved that there. And just remember that dy is undefined when y is 0, though, because of this y on the bottom. So you want to have that there, right? And when y is 0 is when x is equal to positive or negative 2. So you might want to write a note here that dy is undefined when y equals 0. Okay, now when is the curve concave down and when is the curve concave up? So we can look at our image here, right? So when is it concave down? It's concave down in quadrants 1 and quadrant 2. I wish I'd give myself some space here. It's so crammed in there, right? And that's when y is greater than 0. You can see it's down and down, and then it's concave up in quadrants 3 and quadrant 4, which is when y is less than 0, right? Concave up here. So let's try this last one. It can be shown that the second derivative of y with respect to x is negative 4 over 16 y cubed. I just took this and wrote this larger because it's really tiny. Explain how this equation supports your notices about the concavity of the curve. Okay, so what do we know about concavity in the second derivative? Well, we know that if the second derivative here is greater than 0, where are my concavity notes? When the second derivative, let me find those for you, is greater than 0, here we are, these notes, right? When the second derivative is greater than 0, it's concave up. Okay, so let's find when is this thing going to be greater than 0? Well, it's going to be greater than 0 when y is negative. And when is y going to be negative? So we can write all this here if you want to. When y is less than 0, right? Which is going to be what? Quadrants 3 and quadrants 4. I don't know why I write my 3 like that, right? Which is exactly what we had. That is when it's concave up, which is what we said here, this last line. And then the same thing when the second derivative now is less than 0, right? So when it's negative, we would want this bottom part to be negative. So, I'm sorry, to make this negative, we'd want the numerator to be positive, right? Because the numerator, or the denominator to be positive because the numerator is already negative. So that's going to be when y is greater than 0. And when is y greater than 0? In quadrant 1 and quadrant 2. And so what does it mean? If the second derivative is less than 0, well, that's when it's concave down, which is what we had written right here. Concave down. Okay, let's do a couple more problems before we go. Let's try not to make this video too long. I'm going to try my best, okay, I promise. Okay, some things to note. Implicit differentiation can be used to find the first and second derivative of relations, just like you can for regular functions. And critical points are the same thing. It's when the dy dx is equal to 0 or it's undefined. And just like with regular functions, if the derivative is greater than 0, it's increasing. If the derivative is less than 0, it's decreasing. And same thing with concave up and concave down. You're still looking at the second derivative and the sign of that. So let's consider this curve here, x squared minus y squared over 5 equals 1. They tell you the first derivative and they tell you the second derivative. Find the critical points and justify your answer. So the critical points are going to be when the first derivative equals 0. So it's going to be equal to this, right? If we can solve for that, and we also have to find the undefined, but we'll do this first, and then we know the critical points. So when is that going to be true? Well, that's going to be true when x equals 0. What about to make it undefined? To make it undefined, that's going to be when y equals 0, right? We just have a y down there. So we could say the critical points are when x equals 0 or y equals 0. Really what I should go in here and do is you need to kind of do a sign chart for each one, right? So if I plug in a number less than 0, you see it's negative, and then it's going to be positive, right? But it also depends on the sign of y, because you can't do this sign chart anymore because you need the sign of x and y, right? So what happens when they're both negative, when they're both positive? So we can just write this here, right? Those are the critical points because we don't actually have to find the min and the max right now. So that sign chart's a bit confusing. Let's keep going. Is the curve increasing or decreasing in quadrant 4? So in quadrant 4, what do we know about x? And what do we know about y? So we know that x is positive in quadrant 4 and y is negative. Okay, so increasing or decreasing? It comes up here. It's increasing when the derivative is greater than 0 and decreasing when the derivative is less than 0. So dy over dx equals 5x over y. So what happens here when we plug in that positive? Well, we would have a positive on the top. When we plug in a negative, we'd have a negative on the top. So the whole thing would be negative. So we could say the curve is decreasing because dy over dx would be less than 0. All right, now part C is asking us about concavity in quadrant 4. So we still know x is greater than 0 and y is less than 0. But now, because we're talking about concavity, we're going to look at the second derivative. And that's over y cubed? Yeah. Okay. So the sign of y is the only thing that matters here. It's negative. So that would be negative 25 over some negative number, which would be positive, right? So what happens when the second derivative is positive? It's concave up. So the curve is concave up because d squared y over dx squared is greater than 0. All right, number 2 says if x squared times y minus x over y equals negative 2, find dy dx. So this is just having you remember how to find, to do implicit differentiation. I'm not going to do this because I don't want the video to be too long, but I will write the solution if you want to practice that. It's also okay if you don't want to do that right now. This is when we had class for like 90 minutes together last year and we could review things, but this is the solution to that. And then I do want to do number 3 because this is a multiple choice question. It says, which of the following describes the y-coordinates of the point on the curve e to the x equals sine y, where the curve has vertical tangent lines? Okay, so we know that the curve is going to have vertical tangent lines when the slope is equal to 0. So here's the function they gave us, not the function, the relation, right? Keep making that mistake. So let's figure out what the derivative is. So let's take the derivative of each side. All right, this becomes e to the x, and that becomes cosine y times, I'll just say y prime. And so then when we solve for y prime, we get e to the x over cosine y equals y prime. So to find out where there's vertical tangent lines, right? Vertical tangent lines. So that's going to be when it's undefined. And when is it undefined? It's undefined when this denominator equals 0. So then we have to figure out what are the values of y that give you a cosine of 0. Well, that's going to be when y is pi over 2 or when y is 3 pi over 2. Okay. So then I know they actually didn't give me a domain here. I just was thinking about 0 to 2 pi, but it doesn't have a domain. So it's really pi over 2 plus n pi, right? Every 180 degrees, you're going to get a new value that gives you 0. So that is C. Okay, you get some practice on this today, and woohoo, we're done with Unit 5.